So in this video, we're going to calculate the Taylor polynomial for sinh cubed of x centered at x equals 0 up to and including the x to the 9 term. So best place to that is to use our sinh of x Taylor series to begin with. So we know sinh of x, Taylor series approximation of that is a summation from n equals 0 to infinity of x to the 2n plus 1 over 2n plus 1 factorial. And that would get us close to an approximation using a polynomial as we probably need. Okay, now what we do now, let's list this out to get up to the x to the 9 term and see where we go from there. So now I've got sinh of x from that. So plugging in, I want to get up to x to the 9. So 2n plus 1, to make that a 9, I need n equals 4. So let's only concern ourselves with when n goes from 0 to 4. So let's just use that. So when n equals 0, I've got x to the 1 over 1 factorial, which is just x. Okay. Now when n is 1, I've got x cubed over 3 factorial. So I can add x cubed, and then 3 factorial is 6. Next one, I'm going to have x to the 5. So you can see the pattern here. X to the 5 over 5 factorial. So that's going to give me 5 factorial, 120. And then x to the 7 is the next one. So x to the 7, that's going to give me 120 times 6 is 720 times 7, 5040. And then the last one is x to the 9, which I'm not going to work out at the moment, 9 factorial. And this will go on. And the next term will be x to the 11. So I'm going to leave my O notation there as x to the 11. So that will be my approximation using this. Okay, now what we need here is sinh cubed of x. Here we've got sinh of x. So basically what we need to do is to take this and cube it and get terms up to the x to the 9. Now on inspection here, if I get this one twice and multiply it by the largest, I'll get x to the 11. So I don't need this term here. So what I can do is I can just draw a bracket there, put it cubed, and then I don't need these values here. So let's just work with these numbers here. And then what I need to do is do combinations of each to get each one so it's a cubed value of this approximation. So now, if I write that there, that's now going to give me sinh cubed up to x to the 9. So let's bring this down and let's start to cube this out. Okay, so I'm going to multiply it all by itself. I can cube this one and I can cube this one, but I can't cube these two because these will give me 15 and 21 for the indices. So I can cube this and this. So let's put those in. So I've got x cubed. Cubing that, I'll have x to the 9, and then 6 cubed in the denominator, that will give me 216. So that's that one. So that's all the cubed terms. Now let's do with some terms squared. Well, if I square this one, it won't work, and square this one, it won't work, because I'm already up to 10 and 14. That would take me past my 9. But I could technically square this one and square this one and multiply it by different combinations of these. So let's start with this one. So I can square that one and then multiply it with this one, and this one individually. So I've got x cubed times x cubed over 6. So that's what I could do there. And now if I'm doing that in a cubic, what I can do is I'm going to have 3 of those. So now my indice on the top, I'll multiply by 3. So that's that one. Now this one now squared with this one. So let's see what we got there. So I've got x squared times x to the 5, and that's over 120. And same again, there will be 3 combinations of that if that's all written out 3 times. So that one will also be times by 3. And same again with this one and this one. So let's add that one in there. So I've got x squared times x to the 7 times 3, and that's over 5040. So that's picking this one squared with each of these. That'll get me up to x to the 9. Okay, now let's square this one, see where we go. So I'm still adding. So this one squared, so that will give me x to the 6. So let's write there that is x to the 6. And then what am I going to have with that? That will give me 36. And then I can multiply that only with this one. So I've got x to the 6 times over 36, and then times this x. So times x, and the combinations of that, if I've got this one twice, I will also have 3 of those as well. So I'll put that over there, and that'll be 3 of those. So that's that one squared. I've got this one squared, and that's the only 2 squareds I can use. I can't square these. Okay, so now what about the individuals? So now I can multiply this with this with this. So now I've got x times x cubed times x to the 5. So let's just write that up so we can see what's happening there. So x to the 5, and that's over 6 times 120, which I'll just write there 6 times 120. And then how many of this x cubed and x to the 5 is there? Well, as we're trying to cube this, we were going to have 6 of these. So this one can be multiplied by 6. So what do we do now? Well, let's try and simplify this off and put them in ascending orders of the x indices. So now let's rewrite this sinh of x cubed is approximately right. Let's look at the x cubed. So I've got x cubed here, it's the only one. So that will be our first term. Now next we want is x to the 5. So these are going to go by powers of 2. So x to the 5, what's the coefficient for x to the 5? Well, there's an x to the 5, and it's the only one. So x to the 5, and we've got 3 over 6. So let's just write that as 3 over 6, so we keep our pattern and we know where we've got to. Now let's look at x to the 7. Which terms have we got with x to the 7? Well, we've done this one, we've done this one. That's going to give us an x to the 7. So our coefficient is 3 over 120. I know that simplifies, but we're going to just keep that for the moment. So that's done. That's a 9. Here's another 7. So now here we've got 3 over 36. So I'm going to write that as it is written. And that's all of the x to the 7s. Now we want x to the 9. Now this is where things might get a little bit awkward with the coefficient. So we've got x to the 9 here. So that's 3 over 540. Or 5040 I should say. And then one here, we've got 6 divided by 6 over 120 times 120. So I'm just going to write that as it is. So add 6 over 6 times 120. That's going to give you 720. So I can see where that's come from. So that's that one. And I've got one more here. I've got x to the 9 here, and that coefficient is 1 over 216. So add 1 over 216. Okay, right. I'm going to use calculators to work this coefficient out. So now my final answer for sinh cubed of x up to the x to the 9th term is approximately x cubed plus, well, this I know is a half. I don't need a calculator for that. So I'm just going to write x to the 5 over 2. Here I've got x to the 7. So what's that going to give me? So 3 over 120 plus 3 over 36. That's going to give me 13 over 120. So I'm going to rewrite that just to fit my coefficient in there. 13 x to the 7 over 120. And then now let's work out this x to the 9 coefficient. So 3 over 5040. That's that one. 6 over 720. And the last one, 1 over 216. And that's going to give me 41 over 3024. So 41 x to the 9 over 3024. That's up to the x to the 9, but just to finish it off, I'm just going to put my O notation for x to the 11, which will be the next term. And there we go. That's what I'm going to submit as my answer. So that's the Taylor polynomial up to and including sinh, for sinh cubed of x, up to and including the x to the 9 term. Okay.